Hello everybody. Today we are going to be talking about the find the town judge problem. We're going to be starting off in the whiteboard today for reasons that'll be somewhat clear in a bit. So let's go over what the problem is asking for. Find the judge among a group of people in a town. If the town judge exists, then the town judge trusts nobody. Everybody except for the town judge trusts the town judge. Alright, and then it's given an example. Example 1, the n, it takes two parameters. One is n is 4, one is trust, which is going to be a list of lists. And in that list of lists, it goes from 1 to 4, 2 to 4, 3 to 4, and the output would be 4. So the reason for this is what the list represents. As you can see here, person 1 trusts person 4, person 2 trusts person 4, person 3 trusts person 4, but person 4 isn't even mentioned on the list in the first value of the list, so they trust no one. And in example 2, I didn't put the output here, but the output would be -1. I'll just mention that. Alright. So in example 2, person 1 trusts person 2, person 2 trusts person 3, person 3 trusts person 1, and person 3 trusts person 2. In this case, there is no single person in the town. All the people in the town trust someone else, meaning that there can't be a town judge, because a town judge by definition can't trust anyone. So in this example, the output should return -1 because no one trusts anyone. Alright, so to visualize this problem better and to find the approach we're going to be doing, we're going to be using an in-out, we're going to be using an in-degree, out-degree approach. So the reason for that is, basically we can visualize this entire problem as a directed graph type of problem. So this is going to be a problem using graph theory, which we discussed a bit in some of the previous examples. However, previously we talked about graphs and using problem-solving methods that involved breadth first search or a depth first search type approach. This time it's going to be an in-degree, out-degree. And what that essentially means is that we're going to be using a directed graph and considering people as the nodes. So for example, in the first example, we have elements 1, 2, 3, right? So let's switch to the pen tool real quick. Let's draw out. So we'll have person 1. No, that was way too big. 2, 3. And then let's have 4 up here. Basically, in a typical graph, we have nodes and we have edges that just connect the graphs, right? However, in this type of problem, what we're going to be having is, instead of them just being normal edges, they're going to be directional edges. So we can represent these through arrows. So for example, in the first problem here, we can see over here that 1 goes to 4, but 4 doesn't go to 1. It's only a one-way thing. 2 goes to 4, and 3 goes to 4. So we see the node 4 has 3 different approaches going towards him, but he doesn't go towards anyone else. And we can visualize the same kind of thing for this problem too. In this problem, n is 3, so there's only 3 nodes. 1, 2, 3. And in this case, 1 trusts 2, 2 trusts 3, 3 trusts 1, and 3 also trusts 2, so it's going to go both ways. But in this case, there is no town judge here, because that can't be possible, because we need a town judge, and a town judge by definition should not be pointing towards anyone else, like 4 is up here. Yeah, so that's basically it. What we're trying to find is a node specifically that has the value of n minus 1 pointing towards it. So we see here that n is 4, and we have in a node here, we need to find the node that has three arrows pointing towards it, or n minus 1. Whereas every other node, we need to make sure that no nodes are pointing no, not that no nodes are pointing towards them, but we just need to make sure that they're all pointing to that node. Alright, so now let's switch to the code and try to see how this will work. I wrote out the problem here beforehand. Alright, so let's think about the starting off with the most basic situation. The most basic situation is that there's let's write out the function first actually. Def find underscore town judge, probably. Let's do that. And comma trust. Alright, so what we want to see is we want to find a single node where every single other node connects to it, but it doesn't connect to anything else, right? In the directed graph, as we saw earlier, like over here. But let's think about the most basic situation first. So what happens if there's only one node? If n is equal to 1, what happens there? Well, it technically depends. Like, for example, if n is 1, but we see that person trusting someone else, like, for example, like if it trusts itself, then we just return 1. So we have to say if n is equal to 1, meaning that there's no nodes and there's no trust relationships, so both of these things have to be true, then we can just return 1. Because that means that the town judge is that singular node. Because if there's a single node but that node trusts someone else, then we know that, okay, that person is just not that's just some random civilian, not the judge, because the judge doesn't trust anyone. So now let's start by creating the graph representation. So we're going to be doing this by putting this into a table called trust scores. We're going to use we're going to make a trust scores list for every single one, except it's going to be one index larger. We're just going to have one index larger because usually how we list this out, as we noticed in the problem here, there's going to be 4 people, and then there's going to be 1, 2, 3, 4. And we're going to be using the particular indexes, right? But since an index starts at 0, we're going to leave that first index pretty much blank. So that first index is unused because there's no person 0 in this type of problem. So it's taking up one additional array space unnecessarily, but in general, it's not that big of a deal. So now we can we're going to loop through the trust index. So you see how we're taking the trust parameters. The trust is going to be a list inside of a list. So we're going to be looping through each individual element in the list, and to do that in Python, we can just say for a b in trust. So this is going to be looping through the list in A, and then B is going to be the index inside of the lists in that list. For A, B, comma B in trust underscore of A minus equals to 1, and then trust score of B is plus equal to 1. Alright, so what exactly did I just write out here? Basically what we're saying is we're having these reference the two elements inside the matrix. If I didn't make that clear, it's going to be representing the first index of this list and then the second index of this list. So this is going to be A and this is going to be B for each single list in this for each individual list in this big list that's being inputted into this function. What we're going to be continuously doing is, if the person in the beginning, when we see that person, we're going to add it into this trust score list as at that particular index. So for example, in this one, we're going to be working with index 1, and then we're going to be subtracting their score by 1. The reason we're going to be subtracting their score by 1 is because we know that they trust someone, so they can't be the judge. However, if the second person, that second person is someone who is trusted, so they're more likely to be a judge. So they're going to be a potential judge. So we are going to be incrementing that particular index as something that could be a potential judge. So now all we need to do is loop through the trust score list that we have. So this is going to be 1 to n plus 1, because that's going to be looping through this entire trust scores list. If trust score of I is equal to n minus 1. So remember what we said earlier, that what we're looking for in the node is that we're looking for a node which every single node points to, but it doesn't point to any single other node. So in the case up here of 4, we want them to have 3 directed nodes pointing towards them. So 1, 2, 3, and that's n minus 1. So if the trust score of I is equal to n minus 1, then we're going to just be returning I, because that index that we got, that means that's the specific person who is the town judge. So that's basically it. And at the end here, of course, if we never get to this return I function, and it doesn't even hit the base case of there only being one possible node there, if it never hits any of these two conditions, that means that the town doesn't have a judge. So we just return -1. Alright, and that's pretty much it. Let's test the code. So let's say print find underscore town judge of n comma trust. We didn't specify there here, so let's say n is equal to 4. Let's start with 4, and up here we have the trust list. Run this code, and if I'm right, hold on, did I do something wrong? Oh, right, this is the second one thing that I copied. So if n equals to 3, then this entire thing would result in -1. But I'll just copy paste this code real quick. If we see this, the output should be 4. So yeah, basically we see the code working here, and that's all well and good. So thanks for listening, guys, and I'll see you guys next time.